So here we have blue light shining on a metal surface. As you can see, some electrons are being emitted and we got a current of 0.02 amps. I'm going to keep the wavelength the same, but I'm going to increase the intensity of the light. So now you can see more electrons are being emitted and the current has gone up. So why is this? Firstly, intensity is the power per unit area, but because the area is constant here, intensity is just proportional to the power, which depends on the energy of each photon and the number of photons per unit time. Because we've kept the color the same, the frequency the same, the energy of each photon is still the same. So basically increasing intensity here means that we're increasing the number of photons per unit time. So if there are more photons per unit time, there's going to be that one-to-one interaction with the electrons inside the metal. So we're going to have more electrons being emitted per unit time. And this is why the current goes up. What about the speed of the electrons that are coming out, the kinetic energy? So let's look at the equation for the maximum kinetic energy. So we're still using the same photons, the same color of light, so that is constant, and the same metal as well, so that's also constant. So the maximum kinetic energy is still the same. In this question, we have light of a specific wavelength being directed at a metal surface, and it causes electrons to be emitted from the surface. The brightness of the lamp is increased without changing the color. Explain the effect this has on the electrons being emitted. So if we're keeping the wavelength the same, the color the same, that means the photon's energy hasn't changed. All we've done is we've increased the number of photons per unit time. So the number of photons incident per unit time has gone up, and because there's a one-to-one interaction between the photons and electrons, there's going to be more electrons being emitted per unit time. The photons provide the same amount of energy, so E equals hf, and the work function hasn't changed, so the maximum kinetic energy of the electron is still the same as before. This question is slightly more complicated. We've got monochromatic light that's incident on a metal surface, which is causing electrons to be emitted. The wavelength of the light that we're shining on it is decreased without changing the overall intensity of the light. Okay, explain why the current increases at first and then it decreases. Okay, so firstly, the key part here is that we're keeping intensity the same. So if we look at intensity, it depends on the energy of each photon and the number of photons per unit time. So if the wavelength is decreased, we're shortening the wavelength, we're increasing the frequency, the energy of each photon is going to go higher. Okay, so each photon has more energy. Now, if each photon has more energy, it can liberate more electrons from inside the metal. So even the electrons which have lower energy can now be freed. So that's going to increase the current. Secondly, if each photon has more energy, the ones near the surface with the higher energy, when they come out, they will have a higher kinetic energy as well. So the maximum kinetic energy of these electrons also increases. However, coming back to this part where we're keeping intensity the same, how do we keep the intensity constant here? So the only way to do that is you have to decrease the number of photons per unit time. So as each photon's energy goes up, we decrease the number of photons per unit time to keep intensity constant. But because the interaction between the electrons and the photons is one-to-one, as we decrease the number of photons per unit time, that means there's going to be fewer and fewer electrons to it being emitted because there are fewer and fewer photons to be absorbed. Okay, so that's going to cause the currents to start increasing, and that effect comes in more dominant later on.